Inside nearly every computer built over the past few decades, one component quietly powered the entire system: the Central Processing Unit, or CPU. It executes instructions, runs software, and performs the calculations that make modern computing possible. For years, one company defined that technology: Intel. At first glance, Intel appears to be a semiconductor company producing processors for personal computers and servers. Its chips power laptops, desktops, and enterprise systems used across the world. But the story of Intel is not just about manufacturing processors, it is about shaping the architecture of modern computing. Early in the development of personal computers, Intel designed processors that became widely adopted across the industry. These designs established standards for how software interacts with hardware. As more developers built applications compatible with Intel processors, a powerful ecosystem formed. Software, operating systems, and hardware all aligned around a common architecture. This created a strong competitive advantage. The more software optimized for Intel chips, the more valuable those processors became, and the more widely they were used, the more developers continued building for that ecosystem. But maintaining this position required constant innovation. Semiconductor technology advances through smaller and more efficient chip designs. Each new generation of processors must deliver better performance while consuming less power. Achieving this requires advanced manufacturing processes. Intel invested heavily in building its own fabrication facilities capable of producing cutting-edge chips. Unlike many competitors, the company combined both chip design and manufacturing within a single organization. This vertical integration allowed tight coordination. Engineers could design processors and optimize manufacturing processes together, but this is where the strategy becomes more complex. As chip technology advanced, manufacturing became one of the most difficult engineering challenges in the world. Producing smaller transistors requires extreme precision and advanced equipment. Delays in manufacturing development can impact entire product cycles. And this is where competition intensified. Other companies began separating chip design from manufacturing. Some focused on designing processors. Others specialized in manufacturing them. This created a new structure in the semiconductor industry. Specialized manufacturing companies could focus entirely on improving production technology, while design companies focused on architecture and performance. This shift introduced a different competitive dynamic. Instead of one company controlling the entire process, the industry became a network of specialized players. That still was not the only challenge. The rise of new computing demands changed the market. Data centers, artificial intelligence, and mobile devices require different types of processors optimized for specific workloads. Traditional CPU designs remained critical, but other chip architectures began gaining importance in areas such as parallel computing and energy efficiency. This diversification expanded the competitive landscape. Companies now compete not only on raw performance, but on specialization. Some focus on data center computing. Others focus on mobile devices. Others design chips optimized for artificial intelligence workloads. Yet Intel continues to operate across multiple segments. Its processors power enterprise servers, personal computers, and a wide range of computing systems. Behind this product range lies enormous infrastructure. Fabrication facilities operate at global scale, producing chips with microscopic circuits. Supply chains coordinate materials, equipment, and engineering expertise across continents. Research and development teams work on future generations of semiconductor technology. But risks remain. Manufacturing delays, competitive pressure, and shifting technology demands all influence the industry. Semiconductor production requires long-term investment, and each new generation of technology increases complexity. Even small disruptions can affect global supply chains. Yet the core system remains influential. Modern computing still depends on processors executing billions of instructions every second. From personal laptops to cloud data centers, CPUs remain central to digital infrastructure. From the outside, Intel may appear to be a company selling computer chips. But beneath that surface lies a deeper system. a computing architecture shaping how software interacts with hardware, manufacturing facilities producing advanced semiconductor technology, and a competitive industry pushing the limits of performance and efficiency, the future of computing continues evolving. New workloads, new architectures, and new manufacturing techniques will reshape the landscape, but the foundations of modern computing were built on processor architecture, and Intel played a central role in creating that system.